All right, continuing with the series of limits at infinity, let's talk about how do we work with radical functions. So every time we have a function that involves a radical, the technique to algebraically manipulate them is multiplying by the conjugate, right? So when we multiply by the conjugate, we need to multiply by a fraction that is equivalent to 1, and that will remove that root from the expression, like this one in here. And so here, what happens here mostly is that we need to think first, what happens if we just plug the infinity into the function and see if that gives us an answer. Otherwise, then we'll have to manipulate the function. So let's start with infinity, all right? So what happens if we plug infinity into the function? And again, remember, infinity is not a number. Infinity is just telling us behavior. So we're making the x value to increase without bound when we make x going towards infinity. So we need to think about numbers that are extremely large. So then if we plug it, then we have minus infinity plus, and then we have infinity squared minus 3 times infinity, all right? So when we think about this, we need to think about this infinity square is going to grow faster than this 3 times infinity. Remember, this is an like a quadratic function versus a linear. So the quadratic is going to grow faster than the linear. And so because this number is going to be bigger than this one, this expression is going to be positive. So then we have in here a minus infinity plus an infinity for the root inside. We can take that out, and the root of a big number is going to be another big number. And so we have something that looks like this. And so because infinity is, again, is just telling us behavior, and we don't know which of these two numbers is going to be bigger than the other, we won't know if this is going to be a positive or a negative number, or what number would that be for that matter. All right, it's not that we can cancel them each other and say this is a 0, because that's not true. So when we talk about indeterminate forms in mathematics, indeterminate forms, one of them is infinity minus infinity. When we have one infinity that is positive and the other one is negative, we cannot make a decision about this. So then for this first case, though, just plugging the infinity won't work. So then we cannot do this. And we will have to manipulate the function algebraically. And to manipulate that, we are going to multiply times the conjugate. And so we're going to work with this. And the conjugate for this function is going to be minus x. And because this is a positive, then the conjugate is going to be a negative. And then we have the root of x squared minus 3x, and then we're going to multiply, and then the denominator needs to be exactly the same because I need this to be a fraction equivalent to 1, because 1 times the original expression will be the original expression. So I am just keeping everything the same. All right, so then from here, we are going to multiply. So negative x times negative x is a positive x squared. And then a positive times a negative is a negative. And when we multiply roots that are the same, we just keep whatever is in the inside, because a root times a root, they cancel each other out. And then in the denominator, we have minus x minus the root of x squared minus 3x. All right, so now this x squared is going to cancel out with that one because one is positive and the other one is negative. So in this problem right now, we are working with the limit as x approaches infinity of negative and negative is a positive 3x over minus x minus the root of x squared minus 3x. All right. And so here we are back at having that rational with a radical function that we talked about in a previous video. So when we look at this and we try to do kind of the same, if we think about, okay, what happens if I just plug the infinity? So if I plug the infinity, 3 times infinity is going to be infinity. And when you think about the denominator, so we already know that this is going to be an infinity, and we have the infinity here with the minus and the minus. So a big number negative and another big number negative added together doesn't really matter the value of those two. This will be negative infinity anyways, all right? Now, this infinity over infinity, again, because I don't know which of the two is bigger, this fraction could go to infinity, to 0, to whatever. We have no idea. It's not that we can cancel them all each other out because they are not the same number. It's just behavior. One behavior towards positive infinity, the other behavior towards negative infinity. So that is another of our indeterminate forms. So there's nothing we can do with the infinity over infinity. So then just plug in the infinity does nothing to us. So we can ignore that and proceed. And proceed is going to involve finding that largest power in the denominator and divide everything by it. So again, when we do this, I'm going to take that and I'm going to move it down. And then we need to remember that we are going to enclose now something inside of the root. And so let's start by inside of the root, we know this is an x squared, all right? And then we have to go back and think about our little note with the definition of the absolute value. So again, remember that when we take the square root of x squared, this is the absolute value of x because it depends on the original value of the x. And this is x if our x's are positive, and this is minus x if our x's are negative. Oops. Are, oh goodness, are negative. All right. And so because, again, we have to look at where we are. So we are working with all of the x's being positive. So we are right here. And so because we are right there, we are going to use the positive x as our value to divide this and to divide this friend. All right, now we simplify and we use the fact that the limit as x goes towards infinity of a number over x to the power of n is always 0. So continuing over here, the limit as x approaches infinity, we have a 3 in the top because x is going to cancel with the x. Minus x over x is a minus 1. And then inside the root, we have 1 minus 3 over x. All right, so again, this x is going to cancel with this x. That's why we have 3. This x cancels with the x minus 1. This x squared cancels, 1. And then the x and the x squared, we have 1x left. Now from here, again, remember that fractions that look like this, when we apply the limit, it goes to 0. And then now I am left in here with just a bunch of numbers. So we have a 3 in the top. So let me do this. So we have a 3 in the top, and then we have a minus 1 minus the root of 1, which is 1 again. So then this should be negative 3 over 2. All right, minus 1 is minus 2, and then the 3 in the top. Then the answer for that should be negative 3/2. All right, now let me see if I can make this smaller so that I can have a little bit of space. Like that. Okay. Then now I have a little bit of room here to work on the other one. That's not what I wanted to do. All right, there. And let's work with the limit as x approaches minus infinity. All right, and so now multiplying by the conjugate will make the same thing. So then we need to go down to this step in here. So this is going to look like 3x over something, right? Divided by minus x minus the root of x squared minus 3x. And we're dividing everything by something. Now that something is again determined by the value of by the sign of our x's, and our x's are negative. So now because our x's are negative, we are here. So we're going to use minus x. So then if I'm going to use this friend here to decide, then this is going to be minus x, and this is going to be minus x. Then let's simplify this. So we have the limit as x approaches minus infinity. We have a minus 3 in the top because now we have an x over a minus x, so that's a minus. And then in the denominator, oh, I forgot to add the x squared and the x squared here for the inside of the root. All right, so then the next one, x over x is going to be a positive one. Minus root of 1 minus 0. All right, and so I have a 0 in the denominator. So now remember this is behavior. So let me back this up a little bit. So I have a minus 3 in the top because these x's are going to cancel out. And then these x's are going to cancel out, and negative over negative is a positive. Then I have this negative here, and then x squared over x squared is 1 inside of the root. And then I have this minus 3 over x, but then we know that goes to 0, right? Okay, and then now what we have is the limit as x approaches minus infinity of negative 3 over 0. All right, so you see that? We have a 1 here, and we have this 1 here, so 1 minus 1 is 0. Now this is behavior, so this is telling me that this denominator, it's getting smaller and smaller and smaller. And so if you want to try this into your calculator and you divide minus 3 over 0.5, and you divide minus 3 by 0.05, and then minus 3 over 0.005, and you make this number smaller and smaller and smaller, you will notice that this fraction goes towards infinity. Now this is going to be a minus infinity because of the negative 3. All right. Now, I have a better way to show you where this is coming from. Remember that we can always plug it in here and see if it makes sense. So let's see if it makes sense. So let's go back to this expression. And we are trying to find the limit as x approaches minus infinity. So this is going to be the negative, but then now we know that x goes towards minus infinity, plus the root of, we have negative infinity squared minus 3 times minus infinity. All right, I am just plugging the minus infinity where the x's are. So then the first one is going to be infinity because we have a negative times a negative, plus inside of the root, let me make this a little bit down. Inside of the root, negative infinity times negative infinity will be another infinity. And negative 3 times negative infinity will be another infinity. Positive, negative. All right, so let's add minus infinity where I am missing something. Oh, I see where. Okay, I will fix that. Okay, so then this is going to be infinity plus this is going to be an infinity because a big number plus a big number, it will be a big number positive. And when I take the root of that big number, it's going to steal a big number. So then now infinity plus infinity is infinity, all right? And so I'm going to back up in here because I have a negative in here and I know where this is coming from. This is going to be a positive infinity because since all of the x's are positive, so all of my x's are all of my x's are negative, like this, right? All of my x's are going to be negative. So this zero here, I'm actually approaching zero from the left. So if I use the direction, this is going to be a zero that is going to be negative because as I approach zero in the number line, I am actually approaching zero from this side. So these values that I'm making smaller and smaller and smaller and smaller are all negative. And so when I divide -3 over that negative number, the fraction is going to be positive. All right, sorry for the confusion, and I hope that makes sense. All right, and that's how you solve those problems. So you start with the radical, you multiply the radical times the conjugate, and then you treat your result as a rational function involving a radical. So you have to divide by the largest power in the denominator, and you need to use the definition of absolute value to divide all of the terms that are outside of the root. In some occasions, you will be able to do this. And as long as you don't have a undetermined form, like if your forms are, I mean, it's positive or positive, it's going to be positive. There's no doubt about that. But if you have subtractions or you have a division, then these two you cannot solve and you have to manipulate your function algebraically. If you get a positive plus a positive, then you know that's going to be an infinite.